So we want to discuss how to solve 2 by 2 system of equations. So what is a system of equation? Well, it's a system, meaning there's more than one part to it. And in this case, there are just two equations, two unknowns. That's why it's 2 by 2. Okay, there's two equations, so it's a system of equations because there's two equations that are basically working together. All right. In other words, they both have to be true, is the idea. And when we're doing a system of equations, what we're trying to do is solve it. So we're trying to get when is this true? What is the solution that makes both equations work? In other words, what x value and y value are a shared point? And there's three different ways to solve these system of equations: graphically, elimination, and substitution. We're going to talk in this video about graphing to solve. All right. So you look at a solution graphically. The first thing you have to do is you have to graph both lines. So you look at this, y equals minus x plus 3, and you look at y equals 3x minus 1. So I want to graph those. And then what we do is we find the intersection of those two lines. So if you look at this, I've graphed minus x plus 3. You can see it's y-intercept of 3 and a slope of minus 1. So that means you go down 1 and over 1, down 1 over 1. So I graph that line. And then 3x minus 1, you start at minus 1, and when you run 1, you rise 3. And you'll notice the intersection point then is at 1 and 2. So basically, to solve graphically, it's actually quite easy because all you have to do is graph the lines and then find out where they intersect. The difficulty with graphing is that you have to make sure that you're very, very accurate with your graph, or it won't work. So in other words, you have to use a ruler, you have to use graph paper in order to make sure that it's accurate. But then what we can do is, and this is true of any of the ways that we solve this, once you've solved a system of equations, you can actually go back and check to make sure that it is the solution. You can verify it. So what you do is you take each of your equations, minus x plus 3 and 3x minus 1, and we plug in 1 and 2. Okay, so we plug in on the right-hand side and the left-hand side. So over here, y is 2 and y is 2. Okay, so the left side of the equation, that's what LS stands for. They're both 2. The right-hand side, we plug in 1 for x. So we get minus 1 plus 3, and then 3 times 1 minus 1. And we just see, does that actually give us 2? If it does, in other words, the left-hand side is equal to the right-hand side, then we can say, perfect. That is the solution. So we've verified that's what it means, all right? So the idea behind graphing is basically take the two equations, put them on a grid, so graph the lines, and then find out where the lines intersect. Now, based on the way that this looks, in terms of how the equations are presented, you're going to choose a different graphing method. So we've got a number of different graphing methods. You could graph using a table of values, which is slow, but works every time. You can use the slope and intercept. Okay, if it's in the form y equals mx plus b, that's what you want to do. You can find the intercept form. So you can find the x and y intercepts. That's if it's in more this form, okay? So when I say which graphing method would you choose, it's based on what you're given. So what I'm going to look at is, in this case, y equals 1 minus 2x. This is my slope, minus 2. Okay, that's my m. And that's my y-intercept, that's my b. So if this is x and y, and this scale is going to go up by 1, I'm going to start here at 1. And then my slope is minus 2, which means I'm going to run 1 and rise minus 2. So I'm going to end up down here. And then I'm going to draw a line through those 2 points. Okay, so there's my line that's going to go through those 2 points. It's very, very important that you are careful to make sure that your line is going through your points exactly. Okay, because what's going to happen is the lines are going to intersect, and then we're going to read that intersection point off the graph. So you want to make sure we're as accurate as possible. Okay, so this is y equals 1 minus 2x. We're going to do the exact same thing here. So this is my y-intercept here. It's minus 5. So I'm going to go 1, 2, 3, 4, 5 down here at minus 5. Okay. And then the slope is 1. So that means I'm going to run 1 and rise 1. So there's my slope. And again, I'm going to connect it with a line. Now I'm using my computer to draw these lines straight. You can use a ruler to draw them straight. Okay. And then I just got to make sure that it actually goes through each of those points, and I can kind of move it a little bit, and I think that's good. And then once we've drawn it, okay, this is my y equals x minus 5, we have to find the intersection point. And the intersection point looks like it's right here, and it's at 1, 2, and minus 3. So I'm going to say it's at 2 and minus 3. And then I just check my answer. I say, does that actually work? So I go y equals 1 minus 2x, and y is equal to x minus 5. And I plug it in. So I go minus 3 is equal to 1 minus 2 times 2. And I just check to see if that's actually going to give me the same answer on both sides, and it does. I get minus 3 on both sides because 2 times 2 is 4, and 1 minus 4 is minus 3. And then over here, do the same thing. I go minus 3 is equal to 2 minus 5, and that gives me minus 3 is equal to minus 3, and I say, yep, that works as well. So then I know that solution, 2 and minus 3, is the solution. That is the right answer. Okay? So let's do another example with a different method of graphing. So this method, I'm going to use the intercepts. Okay, so if I let x equal 0, then I'm going to get 3y is equal to minus 12, which means y is minus 4. Okay, and then if I let y equal 0, I'm going to get 2x is equal to minus 12, which means that x is minus 6. Okay, so I'm going to draw those 2 points. So at 0, I'm at minus 4. 1, 2, 3, 4. There's 0 and minus 4. Okay, again, you should label your axes and label a scale. So I'm just going to say this is minus 4, and then we know the scale. And I'm going to go back 1, 2, 3, 4, 5, 6. There's my minus 6 and 0. And then I'm going to connect those with a line. And I'm going to try to make it as straight as possible. Okay, and make sure that it's going through those points. Okay, and you may need to adjust it a little bit. If you're using a ruler, obviously it's a little bit different. I can manipulate that line on my computer. You may not be able to. Okay, then I'm going to do the same thing with this one. I'm going to use the exact same method. So I'm going to let x equal 0. If x is 0, I get minus y is minus 4, which means y is 4. Then if y is 0, I get 2x is equal to minus 4, which means x is minus 2. So I'm going to plot those. So at 0, I'm at 4. And then at minus 2 right here. Okay, that's minus 2 and 0. And again, I'm going to draw a line through those points. So I'm going to try to make that, again, as straight as possible and make sure that it's going through those points as good as I can. And then once you've drawn the 2 lines, there's my intersection point. And I just count. I go minus 1, minus 2, minus 3, and minus 2. So I'm saying my intersection point's at minus 3 and minus 2. And then we just check our answer. We see if it works. Okay, so I go 2x plus 3y is equal to minus 12. That's the first one I'm supposed to check. So 2 times minus 3 plus 3 times minus 2. I didn't write the negative in there. I should have. It's at minus 2. I said minus 2, I think, but I forgot to write it. So that equals minus 12. So let's see if it works. I get minus 6 is minus 12. So minus 12 is minus 12. So it works for that one. Yep, that works. Then I try the other one. So the other one is 2x minus y is supposed to equal minus 4. So I go 2 times minus 3 minus minus 2 is supposed to equal minus 4. Let's see if it does. That's going to be minus 6 and then plus 2. And I get minus 4 equals minus 4. Okay, so I'm right again, and I'm happy about that. That works. So I can say with confidence that my answer is correct, that minus 3 minus 2 is the right answer. Okay, so that's the idea behind graphing. So there's a couple here for you to try, and I'm not going to do them with you in the video. I think it's fairly obvious. As long as you know how to graph, then the rest of it's pretty easy. But I would caution you again that this method works great if you draw the graphs right. If you're not careful with graphing, so if you're not using grid paper, you're not using straight lines, that's why I'm using graph paper and I'm using the line that's here, so I'm not trying to do it by hand. then you'll do fine. But if you don't do those things, you will end up potentially with the wrong answer simply because your graph isn't drawn right or it's not drawn carefully. So there's a couple for you to try, and there's a couple more in your textbook, and you can try those on your own.